Welcome to Emerging Technology Horizons. I'm Dr. Mark Lewis. I'm the Executive Director of the Emerging Technology Institute at the National Defense Industrial Association. And today we'll be talking about various issues related to autonomy, and especially autonomous aircraft operations. And to do that, I'm joined by two of the leaders of an organization called Merlin Labs. Matt George, who's the Chief Executive Officer at Merlin Labs, and then Ashley Pelzek, who is the Vice President of Business Operations at Merlin Labs. They each come to Merlin with very interesting background. Matt has been the CEO at Merlin for about 3.5 years now. He was also the CEO and founder of a company called Bridge. He spent 4 years there. He's had a robust history in entrepreneurship and in the defense sector. A Bachelor of Arts in Biology from Middlebury College, and he went to paramedic school at Texas A&M. So again, really interesting background, and he's a private aircraft pilot as well, instrument rated. Ashley has joined Merlin Labs with a background from MIT Sloan School of Management. She was an associate at McKinsey and Company, had a worked with Amazon, but I also find it notable that she was an F-18 training officer. And so really has a pilot's perspective as well as to what automation can do in the cockpit. So Ashley, Matt, thank you so much for joining me on this episode. And could I start off? Could you tell us about Merlin Labs? What do you guys do?
Yeah, so Dr. Lewis, thank you so much for having us. So the best way to think about what we're doing at Merlin Labs is making every little kid's dream come true, right? Which is when you ask like a kid what the future looks like, they draw some variant of Jetsons flying cars flying around and sort of autonomous vehicles and things like that. We're taking a really stepwise, practical approach to be able to go get there. So to get to that end state, end future, what we're doing is we're creating the world's most experienced, capable, flexible pilot. So taking everything that's happening in a pilot's head, putting that in software, and then enabling our partners and customers to be able to go leverage that hardware and software to at first augment human crews, then enable aircraft to operate with reduced crews, and then deliver on that end state, which is to deliver fully uncrewed aircraft. So taking a really crawl, walk, run approach to be able to go get there and to really redefine how we utilize the sky above us.
Very good. So again, that approach, frankly, to me makes so much sense, right? Instead of trying to jump immediately to a fully autonomous aircraft, as you say, doing the autonomous aid, then reducing crew count, so you've still got a crew member, and then eventually moving to this future where we've got, well, arguably crewless airplanes. But what have you done so far? I know you've got actual hardware operational. You got aircraft flying. Tell us what you've done.
Yeah, I think we're really proud of sort of the progress that we've made in a relatively short period of time. So first off, we built an incredible team that is the underpinning of all this. So the outputs and everything everybody sees, that is just a byproduct of the team that we've been able to go assemble, which we're really proud of and is really sort of the core to our success here. So what we've done is we started out with like a very experimental code base. We took a bunch of software and put it in a small canard composite aircraft, which is a under 2,000 pound aircraft. Literally duct taped together hardware, software, got it up flying within about 4 months of our seed round. So, we got the money in the door, and then, within about 4 months, we were actually up flying an aircraft. We then took a step back and developed, what we're flying now, which is our own totally proprietary, robust code base. And we have demonstrated that now in a wide variety of aircraft, up to including very complex twin turboprop aircraft. We're also really proud of the fact that we're the only group in the world that has gotten certification basis from a major regulator on takeoff to touchdown autonomy. I think many people are surprised by the fact that, given how autonomous aircraft are, or at least how automated aircraft are already, that there's never been an aircraft certified to go from 0 miles an hour on the runway, do an autonomous takeoff, fly en route, be able to go interact with air traffic control, and land. So we're the first group in the world that has gotten certification basis on a full takeoff to touchdown autonomy system, still with the safety pilot aboard. That's a really foundational step, both for our civilian and DoD customers, to be able to go build that end state future and lay that solid foundation to be able to go get there. So in addition to the technical certification progress, we have a robust network of partners, including a lot of work and a lot of partners at the United States Air Force, and then across the DoD. We've announced partnerships like Ameriflight, which is the world's largest Part 135 airline, and we've grown a robust network of partners, collaborators, and customers, including folks like Dynamic Aviation, who are using our technology and deploying our technology to meet real end user needs.
So if I take a step back, so you're starting out with autonomy in the cockpit. So essentially, I know you're trying to first reduce the number of people required in the cockpit. So pilot, and instead of co-pilot, you'd have an autonomous system. Tell us a little bit about how it would operate.
Yeah. So we fundamentally believe that the way to be able to deploy autonomy is with a human pilot supervising the autonomy first. We're generally pretty skeptical of anybody who talks about going right to totally uncrewed aircraft, even if there is remote pilot monitoring, because then that link to the ground becomes a safety critical component. So in the system that we're flying out in California now, the pilot on the ground arms the system. The system takes off, talks to air traffic control. We sort of do a bunch of simulated work, especially in our test area. And the human pilot is just there monitoring the aircraft. So it's a pretty seamless integration. The system is doing all of the work to be able to go understand natural language, be able to, sort of go respond back, and then land. So the human pilot is there to monitor the aircraft. That's a really important role. So unlike autonomous cars where if something goes wrong, you can sort of pull over and turn on the flashers. In a totally autonomous aircraft without a safety pilot aboard, you don't have that option. So that interaction, even though it's very minimal with the human crew members, is really important for us.
So is the goal to create a co-pilot who from the outside is indistinguishable from a human co-pilot?
Yeah. So unfortunately, it's not like the movie Airplane.
Okay, so you don't have the autopilot for any of us who remember that reference.
The autopilot. Yeah.
Yeah.
So if you were to step in one of our aircraft, unless you knew really where to look, you wouldn't know that there's an autonomy system aboard. Okay. So it's not like a big robot. It's not like auto.
Yeah, no inflatable.
No inflatable from the movie Airplane.
Yeah.
But the system is modular. So we've taken the system onto a wide variety of aircraft. With the same set of hardware and the same general sets of software, we've been able to go to integrated on 5 different aircraft types with the same set of hardware and software, allowing our customers to be able to go utilize it on a wide variety of aircraft. With the exception of a very small number of airlines in the world, most operators operate a wide variety of aircraft. So that modularity is really important for them.
So could you tell us a little bit about, do you do machine learning? Does the autopilot learn the airplane? How are you actually, without giving away proprietary, but what's your secret sauce?
Yeah, with no proprietary, but I will not tell you the secret sauce.
Okay.
So we have developed the system with certification in mind. So it's really easy to be able to go do a science project and be able to go sort of throw up a science project and put it up into the sky. But ultimately, those things are not certifiable. So what we've had to go build is a deterministic system. So inherently AI and machine learning is non-deterministic. So we've had to build a deterministic system, and then in a way that's pretty creative and pretty unique to us, and is part of our special sauce actually. This is to be able to go take machine learned elements, so non-deterministic elements, and then imbue them into a deterministic system in a way that the regulator is comfortable with. So for us, it's a mix of AI, machine learning, and then mixed with very classic deterministic autonomy that enables us to be able to go do this, but also more importantly enables us to be able to go and certify it. To your question about how it learns, when we learn a new aircraft, we take one of our military test pilots, who are some of the best in the world. And fly the aircraft for a number of hours. The system sits, learns, and we're able to then develop gains, and sort of tuning for each one of those aircraft, which enables that modularity between aircraft.
Is it a difficult process to import this to each new aircraft? It's gotten
easier and easier. So certainly for aircraft type 1 to aircraft type 2 is a huge struggle. So we're about to go fly a brand new aircraft type that the system has never flown before. And it's gone from months to weeks and now to days. which has been really, really exciting. So the system's getting much smarter, just like a human pilot. When a human pilot, is exposed to more aircraft, we're able to, move much more quickly between aircraft. But yeah, there's still a lift when we go to new aircraft, just like there would be for a human pilot as a human pilot learns new aircraft.
So can we move a little bit, talk about the future? So you mentioned you're aligned with the U.S. Air Force. Right off the bat, this seems to me a great technology for helping to solve some of the challenges we have with the pilot shortages that we're seeing. Right, fewer people in the cockpit. It should, in theory, reduce operational costs, but also manpower requirements as well. But let's think down the road. As an emerging technology, autonomy is one of the key areas we're looking. Where do you see this ultimately going for the Department of Defense?
Yeah, I can chime in here too, if helpful. So I think there's a lot of different use cases for it. So when you talk to folks about the types of missions, right, where this is applicable, it's really dull, dirty, dangerous, right? And so when you think of the near peer advanced threat environment, especially that, we've always referenced that environment, but it's becoming more and more of a realistic environment these days. I think you start to see that the number of people that you have on board is certainly, something that the military really wants to draw down on. So if you can preserve human capital going downrange into threat territory, those are significant use cases. And then it's also specific to aircraft type. So when you think about, which aircraft you need to forward deploy, you're thinking tankers, you're thinking logistics aircraft. Again, if you can now reduce the crew or remove them altogether for a large transport aircraft to move goods, to move people, that's a significantly attractive use case for the military. I also think that the ability to reduce crew for the forward deployed, like I mentioned, tankers earlier, I think that's going to be a heavily targeted asset. And you don't necessarily need all those people aboard, especially with the advanced tanker capabilities that they're also creating with new aircraft. So those are two very, very specific ones. But there's applications to a bunch of aircraft. There's a lot of interest in red air, so adversary flight aircraft, just being able to utilize pilots more for what they're designed for. When I was in the Navy, I spent probably a third of my career flying red air missions. Is that a good use of air crew? Probably not. We could probably have some sort of drone capability or a Merlin system aboard some of those red air aircraft. And so it really has use cases with every single different aircraft you could see. And I also, and Matt will speak more on this too, the way they're starting to think is how do we create air crew or pilots that are battle space managers? So how do they go out there and do the thing they're actually designed to do? So the lead pilot of an F-35 can now actually go dictate where its different assets are going, where people need to be placed, as opposed to just simply flying the aircraft. And there is a lot of automation aboard those, generation or fifth generation aircraft, but we can, also assist in that. And now you allow the other unmanned or uncrewed aircraft to go do, more important parts of the mission without having to worry about, putting assets downrange as well.
Yeah, absolutely, absolutely. So if I extrapolate, you both mentioned that at some point down the road, you're looking to the fully autonomous aircraft. And give me your thoughts on that. How far down the road is that? And then what would that actually look like?
Be a little bit controversial here.
Go. We love controversy. Go.
And say that it's pretty far down the road. We think that the really difficult challenge is what we're describing, which is how do you go from 2 crew down to 1? And that's an incredible problem. And if you solve that problem, you solve a huge swath of sort of mission needs for the Air Force. We also, especially as we sort of move to very cognitively intense sort of flying, especially with near peer competitors, being able to go have those human pilots and human brains, thinking and making decisions is really, really important. So being able to go reduce crew on those missions where you're able to go take, aircraft that are moving milk and mail, as Ashley said, the dull, dirty, dangerous missions, reducing crew there, we think is the earliest and the most impactful problem. And by the way, the only way to get to that unmanned end state. So we don't take a pilot and say, okay, go right and go to that aircraft and go have fun, right? We take that pilot and we take her, him, and progressively move them through, more complex aircraft types and have them get experience. And that's exactly what we're doing. So we're driving that unmanned end state. But we are really focused on the opportunity in front of us, which is providing our customers and partners with a highly autonomous capability that allows them to be able to go take their existing assets, existing people, and enable those existing assets and people to do more
Interesting.
things.
I have to admit, I admire the sober view that going to the fully autonomous large airplane is, yeah.
Yeah, and
Yeah.
I mean, don't get me wrong, right? Like we're driving towards that, but at the end of the day, right? Like there's no skip a step. There's no magic skip a step here. You have to be able to go develop that pilot, put that pilot in the co-pilot seat for a really long time before you have confidence to be able to go move that pilot, the autonomous pilot, to be the sole air crew.
There's the old joke that in the future the cockpit will have the robot, the pilot, and a dog. And the joke is the dog is there in case the pilot actually tries to do anything to bite the pilot. Almost blew.
My dog flies
Okay.
with me and falls asleep. So I don't know. Yeah.
So I kind of want to step back. You were talking about the certification process, and I think you very properly emphasized that as having been a significant accomplishment. How challenging was that? How much of a hurdle was that to get through?
It's hugely challenging, and we're not all the way through it yet, right? So like we're through the certification basis, which is the big sort of scary part of the process, but like we still have a long way to go. And certification is the most underestimated part of the process for any new aerospace company. You can have the best, coolest demo in the world, but like unless it's certified, you have the best, coolest demo in the world, nothing else. So we have constructed our team around certification, led by Cindy Comer, who leads our certification group. And we've invested a disproportionate amount of money and resources in our certification organization. It's paid dividends, for us. So that process is really hard. It's not just sort of regulatory of going and talking to policy people, but it's down to sort of the nuts and bolts of how do you put together hardware? How do you write code? How do you set requirements? These are things that are really core to the product, and you can't do it post fact, right? So you have a lot of companies that go, all right, we have this cool thing, let's go certify it. And they're in for a rude awakening. Being able to go build stuff from the ground up around certification is the only way to do it, and something we're super proud of here at Merlin.
You've been a bit of a trailblazer. Dare I ask, do you think others seeking similar certifications will have an easier time? Have you basically shown the government how to do this, or are we still everyone will be a case by case basis?
I don't know if we're competent enough to say that we can teach the government any lessons. We've definitely made it easier for other people. With that said, the certification process is so bespoke to each project that we have certainly made it easier, but not by much. So the way that we're approaching this is pretty new, novel. The way that we're collaborating with regulators is pretty new and novel. But I think that's the case with anybody who is moving first in a market. You're going to make it a little bit easier for the folks following. But for us, that advantage is huge and compounding. So because we have a big certification advantage, it's enabled us to go land customers that other people have not been able to go land. And because we've been able to go land those customers, those partnerships, we've been able to go raise more money than others. And it starts to become a really interesting flywheel that allows us to be able to go build, a tremendous amount of progress and put a lot of blue water between us and those looking to catch up with us.
If I can switch gears a little bit, I'm really interested in maybe what I'd call maybe the customer experience isn't quite right, but I'm envisioning the troop transport aircraft, which instead of two pilots in the cockpit, it's got pilot and a machine, or maybe far future two machines. How do you convince the folks in the back, the passengers, that hey, it's all cool, it's all good, or do you have to?
I think there's a broader question before that too. It's just public and social license in general. Convincing folks of allowing this to fly overhead, certain areas. And I know Matt touched on crawl walk run earlier, and I know he's probably laughing at this because we talk about crawl walk run all the time, but it literally applies to everything we do. And so getting public buy-in, whether that's just accepting the technology in the first place, then putting these aircraft overhead potentially populated areas, then putting people in them. That's also crawl, walk, run. And so to directly answer your question, I think it goes back to credibility. We have to have tons of flights. We have to have, thousands and thousands of hours with the system on. And one of the things I also want to add to that is we've made this system very user friendly. That's why we have military test pilots building the system, and they're the ones that are doing all the tests every day. It's so that when a pilot does get in there that's a potential or future customer, they say, wow, this is really easy to use. Because I've seen in the past where test cases come along, you get a new system or a new part of the system, and then it's actually harder to use than before. And of course, people just immediately ignore it. And that'd be really terrible for anybody in our industry. And so all of that to say, back to your direct question, we think about these things very strategically and very, very much down to the detail. I think the way we'll get to that trust and getting people on board, which I believe is, probably decades down the road, and I think Matt agrees, is having all of these, military test cases, having the commercial cargo use case, and that's actually why we picked those early on to
Yeah.
build this out.
Yeah. No, it makes a tremendous amount of sense. Of course, I'll also point out, with all due respect to my pilot friends, that the most common cause of an accident of air accidents is pilot error. Now, of course, that's
Yep.
often the case because the pilot is not around to defend themselves. We,
Sure.
and lots of examples I can think of where an autonomous system aiding the pilot would obviously increase the safety of the aircraft and getting
Yeah, and
that
that's
point
why
across. Yeah. Oh,
that's
I'm sorry.
why
Go ahead.
so many of us got involved with this. You're absolutely right. That's what piqued my interest when I initially, came to Merlin. I think that's a huge reason why our test pilots are involved. We've all lost friends in instances where we probably didn't need to, and
Yeah.
something like this that either could have overridden or helped or aided in really difficult situations would have been really crucial. So
Right. I know just last year the Collier Trophy was awarded to the group that developed the ground avoidance system that has already saved lives. I guess a maybe a much more primitive version of the autonomy that you're developing, but still shows the power of this capability. So wonderful. Tell us where you see Merlin going, and you've laid out your vision for technology, vision for the future. Do you eventually see yourselves in every DoD cockpit, every commercial cockpit? What does the future look like for Merlin Labs?
Yeah, so I mean, we're building the world's most experienced, capable pilot. So where there is a pilot, there is Merlin. So we're starting out with some limited use cases. So it'll start DoD first, cargo second, and then sort of escalating from there. So yeah, we're applicable to anything that is flown with a pilot today, which is really exciting. We're not presupposing any use cases. We're not presupposing any markets. We're delivering sort of a picks and shovels solution into the market where we are developing that sort of autonomous pilot that really is able to go define how the next 100 years of aviation works. The past 100 years have been built around a pilot. The next 100 years are going to be built around autonomy, and we're creating that system of record to be able to go power the next 100 years, both for today's use cases, the stuff that we can imagine, but also the stuff in the future that we can't imagine. So if you allow a human to be able to go put a very large object up in the sky and have that large object go do something useful and interesting, people will use that in new and innovative and creative ways that we haven't thought about before. It's certainly cliche, but things like Uber were not possible before the iPhone. So by providing a platform where we're enabling a bunch of new use cases, we're really excited to see A, how Merlin will be applied to existing use cases, but B, what new use cases that Merlin will enable to be able to go serve
Absolutely.
the world better from the air.
I'm even imagining, when I was in the Pentagon, we spent a fair amount of time talking about the wingman concept, where you've got pilot in the aircraft, but then you've got autonomous aircraft that are working alongside of them. And it seems to me that you've also got the potential. Hey, patent this idea if it's not already in your thinking. I'm sure it already is, but you've got the potential to not only provide an aid to the pilot in the cockpit, but also to provide an aid in working with these other autonomous systems that might be flying along.
Yeah, no, 100%, right? So we always fundamentally believe
Mm-hmm.
that there has to be a human in the loop, especially when we start to sort of look sort of farther afield. But by developing that really capable pilot, you can then start to add new capabilities to that pilot, have that be able to go interact with other systems, I think in a way that's really interesting, built on sort of that foundational certified autonomy. So absolutely something we're thinking about, but really focused on the sort of the cargo and some of the less fun but more tractable use cases first.
I guess last question. We're running low on time, but I do know there's obviously tremendous interest in air mobility, and you started off talking a little bit about the Jetsons flying car, and I know that's not what you're doing, but there are so many companies now that are trying to enter that space. Where do you see your technology contributing to the personal transport vehicle, or does it?
No, it certainly does. And, I think what we're doing, we collaborate with a lot of those companies. A lot of those companies, especially in the eVTOL companies in sort of the personal air mobility or group air mobility space, they're really focused on building and certifying their aircraft with a bunch of very new technology, that they're going to be really heads down certifying. What we're doing in parallel is developing autonomy. So we think that these two things come together in a really interesting way in the not so distant future that enables those types of aircraft to be flown by the Merlin pilot to be able to go, to do all the missions that they're talking about. So we're bullish on it. We think there's a lot of good folks in the space. Folks like Joby, Beta Technologies up in Vermont, they're who are doing some really, really interesting things. And we're happy to be able to go support them by building that autonomy system that will eventually be able to go and sort of assist them in serving their users and their missions.
Well, Matthew, Ashley, thank you so much for joining me for this episode. It's the work that you're doing. Obviously has so many interesting applications in the Department of Defense. Really looking forward to seeing how your technology progresses, how your work continues. I'm going to be a tremendous contributor. So again, thank you for joining me for this episode. It's been great talking to you.
Thanks for having us.
Okay. Thanks, Dr. Lewis.